Typical amperage for residential service generally falls between 100 and 200 amps for single-family homes with moderate to heavy electrical usage, such as heating, cooling, and standard appliances. Larger homes or those with significant electrical loads, like electric vehicles, pool pumps, or large workshops, may require 200 to 400 amps. When evaluating the customer's situation, consider several factors. Firstly, the meter size can be a strong indicator of the maximum amperage the electrical panel can handle. If the meter is rated for 100 amps, it's less likely the power company installed wiring meant for a higher amperage. Secondly, wire size is crucial. 100 amp service typically uses number 2 copper wire, which is noticeably thinner than the number 4 or 2/0 wire used for 200 amp or 400 amp services. The presence of larger wires at a neighboring house might suggest the power company upgraded that service at some point, but it doesn't automatically mean the customer's wiring is inadequate. Several possible explanations could account for the observed situation. The power company might have recently upgraded the service to the customer's house, installing 100 amp wiring to comply with current code requirements. Also, the 100 amp wires might be run through a conduit, which provides protection and can allow for a higher amperage capacity than open-air wiring of the same size. Finally, there could be unique circumstances that justify the use of smaller wires, such as the proximity of a substation or the length of the service line. To determine the actual situation, a recommended course of action includes these steps. Firstly, verify the meter size to confirm its amperage rating. Secondly, carefully inspect the wire size where it connects to the house and measure the wire's diameter. Finally, contacting the power company directly is advisable. Inquire about the amperage of the service line and the reasons behind the 100 amp wiring. They can provide specific details and relevant documentation about the installation. The National Electrical Code, or NEC, provides guidelines for electrical installations. Although the specific edition in use is the 2017 NEC, the principles remain consistent across different editions. Several articles within the NEC are particularly relevant to this situation. Article 220 covers branch circuit, feeder, and service calculations, essential for determining the appropriate size of conductors and overcurrent protection. Article 230 addresses services, including the size and rating of service entrance conductors. Table 310.15b16, often referred to as Table 310.16 in older versions of the code, specifies the allowable ampacities of insulated conductors rated up to and including 2000 volts, with not more than 3 current-carrying conductors in a raceway or cable or earth, based on ambient temperature and conductor temperature rating. For example, if the conductors are rated for 75 degrees Celsius and the ambient temperature is within the standard range, number 2 copper wire is typically rated for 95 amps, which is suitable for a 100 amp service when using a standard overcurrent device. Number 4 copper wire, under similar conditions, is typically rated for 70 or 85 amps, depending on the installation type, making it suitable for some lower amperage services but generally not for 100 amps. Number 2/0 copper wire can carry significantly more current, often around 175 amps or more, depending on insulation and conditions, and is suitable for services of 200 amps or higher. When evaluating the existing electrical service, several calculations need to be performed to ensure code compliance and safety. Firstly, calculate the total load of the dwelling unit following the procedures outlined in NEC Article 220. This involves determining the general lighting load, small appliance and laundry circuit loads, and the loads of any specific appliances or equipment. For general lighting, a load of 3 volt amps per square foot is typically used. Small appliance circuits, which serve kitchen and dining areas, require at least 2 20 amp circuits, each calculated at 1500 volt amps. A single laundry circuit, also rated at 20 amps, is calculated at 1500 volt amps. Any fixed appliances, such as water heaters, ranges, and air conditioners, must be included at their nameplate ratings. After calculating the total connected load, apply any applicable demand factors as permitted by the NEC. Demand factors allow for a reduction in the calculated load based on the understanding that not all connected loads will be operating simultaneously. For example, NEC Table 220.42 provides demand factors for general lighting loads in dwelling units, which may allow for a reduction of the load based on the total square footage. Once the final calculated load is determined, select the appropriate size of service entrance conductors and overcurrent protection. The service entrance conductors must have an ampacity equal to or greater than the calculated load, and the overcurrent protection device, typically a circuit breaker or fuse, must protect the conductors from overcurrent. The size of the service equipment, including the meter socket and main service disconnect, must also be adequate for the calculated load. If the existing 100 amp service is found to be inadequate for the dwelling's actual load, an upgrade may be necessary. This involves increasing the size of the service entrance conductors, upgrading the meter socket and main service disconnect, and potentially upgrading the electrical panel to accommodate additional circuits. Any electrical work must be performed by a qualified electrician in accordance with all applicable codes and regulations. A permit is typically required for service upgrades, and the work must be inspected by a local electrical inspector to ensure compliance with the NEC. The power company should also be notified of any planned service upgrades, as they may need to upgrade their equipment to accommodate the increased load. Considerations for specific equipment include electric vehicle charging. Electric vehicle chargers can add a significant load to a residential electrical system. A level 2 charger, which operates at 240 volts, can draw anywhere from 16 to 80 amps, depending on the charger's rating and the vehicle's charging capabilities. Before installing an electric vehicle charger, it's essential to perform a load calculation to ensure the existing service has sufficient capacity. If the existing service is not adequate, an upgrade may be necessary. Pool pumps also represent a significant electrical load, especially for larger pools with powerful pumps. The NEC requires that pool pumps be connected to a dedicated circuit and that ground fault circuit interrupter protection be provided. The size of the conductors and overcurrent protection for the pool pump motor must be determined based on the motor's nameplate rating and the requirements of NEC Article 430. Large workshops with power tools and equipment can also place a heavy demand on the electrical system. Each tool or piece of equipment must be connected to a circuit with adequate capacity, and the workshop should have sufficient branch circuits to accommodate all of the anticipated loads. If the workshop includes welding equipment or other heavy machinery, a dedicated service may be necessary. In summary, determining the appropriate amperage for a residential electrical service requires a thorough evaluation of the dwelling's electrical loads, compliance with applicable codes and regulations, and consultation with qualified professionals.